Okay, hello. I want to actually talk a little bit about exponential and logarithmic equations here today. It's not related to the derivatives. If you remember, we talked about the Euler function and natural logarithm. It would be also good to learn how to solve equations, exponential equations and logarithmic equations, because I have seen some questions of this type also in the national exam. So let me just start with an example. I just want to present some examples for you and try to solve them, okay? Solve each of the following equations. Okay, so let me start with a very simple one. So I would write 2 to power x is 3. So we want to solve this equation. Of course, this is some question that in principle you should be able to answer it when you are doing Math 2C. So if I want to solve this, what can I do? First of all, I want you to understand what is the main difference between this equation and the equation that we had so far is that here x, the unknown, appears in the exponent. Whenever this happens, that equation is called an exponential equation. Okay? And for solving an exponential equation, what you need to remember is probably you need to use logarithm at some point. Whenever you are supposed to find an unknown which appears in the exponent, it's always good to remind yourself about the idea of logarithm. Okay, so for this one, in Math 2C, we could take logarithm in the base to the base 2 from both sides. Yes, I can write, so let me write method 1. I would say that I take logarithm from the left and right, but I would choose base 2 for that. The reason that I choose base 2 becomes clear right now, yes? What can I do? I can use the rules of logarithm. This power that appears here now goes to the back of the log, so it becomes x times log of 2 to the base 2. On the right-hand side, I cannot do anything with that because that is not a number I can guess. I just keep it like this. Of course, if you want to know more about this number, you can use your calculator or the computer. But now log of 2 to the base 2 is 1, and then x is left alone here, and the right hand side is log of 3 to the base 2. So if you provide this answer, that's completely acceptable. Yes, so that is the solution to this. Method 1, method 2, usually when you want to work with logs, you might prefer to work with logs to the base 10 because that's more standard. That is also possible. So let me write method 2. So instead of taking logs to the base 2, I take logs to the base 10. But you know that if it is 10, I don't write it down. And now what happens? Exactly the same situation because that's also a log. So x goes to the back. But now the point is that if I choose base 10, this cannot be simplified further. So log of 2 is just log of 2. But I want to isolate x to find x. So I have to divide everything by this coefficient. So then x becomes log of 3 divided by log of 2. So if you provide that answer, that is also correct. And actually these two numbers are exactly equal. If you go back and review my lessons when I was teaching you the logarithm, this is the base change formula for the logarithm. If you want, I can remind you, but this is not in the book. So let me just write it here. So if you have log of a to the base b. You can choose another base, whatever you want to, and write the log there. So this is also, of course, b should be an acceptable base, meaning that it should be positive, not equal to 1, c the same, a should also be positive. If you respect all these conditions, that formula is correct. So this is why this number and that number are the same. So it depends which one you want to use. But now method 3, we just learned about natural logarithm. So I would myself prefer always work with the natural logarithm. So method 3, I would say that we use natural logarithm, yes? But that's also the same story. So it means that you write 2 to the x is equal to 3. You take ln from both sides, yes? And then what happens again? This x goes back to the ln. And then you want to isolate x, so you divide everything by ln of 2. You get ln of 3, ln of 2. That is also correct. And of course, you can check this with your calculator. All these three numbers are exactly the same. So in our lesson, it's better to always work with natural logarithm. Okay? Here, it doesn't really matter which one you choose. But if you have an exponential equation so that e is involved, I would always recommend you to use the natural logarithm. For example, what do I mean by that? So let me give you another example. Assume that I give you to solve this equation. E to power 2x is 4. In this case, I really prefer to use the natural logarithm. Okay, so even though again you can choose log in any base, but it is more natural here to use the natural logarithm because here the base is e. This is the best choice. So whenever you want to solve an equation of this type, in which somehow e is involved and your unknown is in the exponent, use natural logarithm to solve it. So what I do, I take ln from both sides. And you know that natural logarithm is also a logarithm, so it enjoys all the properties. So 2x goes to the back. But this is something that you need to know really. ln of e is what? Yes? It's 1. So then this is just 1, it becomes 2x, is ln of 4. But I am looking for x, so I have to isolate x. I divide everything by 2. And by the way, when I ask you to solve it, I want you to solve it exactly. If I want you to give me approximate values, I will explicitly mention it in the problem. Of course, you can stop here, but I myself prefer to simplify it a little bit more. Can you simplify this? Yes?
Write 2 as a logarithm.
How? But that does not help. Because if you want to write 2 as a logarithm, so what do you want to write? You have to write ln of e to power 2. And then you have ln of 4 divided by ln of e to power 2. You can write nothing. So I prefer to write 4 to 2 power 2, yes? Yes, if you want to simplify that. By the way, this is something you need to know very well. So instead of 4, I put 2 to the power of 2. And then I have a 2 here. But you know that this 2 goes to the back. So then it becomes 2 ln of 2 divided by 2. What is the answer now? It's just simply ln of 2, which is ln of 2. So the answer to this problem is simply x equals to ln of 2. Yes? Is there any question? Okay, for example, I can write one more. So number 3. Well, I can write 5e to the power of 1 minus 2x equal plus 2 is equal to 8, for example. We want to find x. So what should we do first? I want to try to isolate x. So the first step, probably you can guess, I move 2 to the other side. So I will have 5e to the power of 1 minus 2x. Let us move this to the other side. It becomes negative 2, positive 8. It becomes positive 6. My goal is to isolate x, so next I get rid of this 5. So I divide everything by 5. But this is more or less comparable to what I had before. So you have e to some unknown power is equal to a number. So the trick is to take the ln. So I take ln from both sides. But you know that this goes to the back. This becomes 1 minus 2x, but you have to be careful that you have to put pair of brackets. And then you have ln of e, and then you have ln of 5 over 6. But ln of e is also, I told you, is just something you need to know. This number is just 1. Then it means that I have 1 minus 2x, which is equal to ln of 5 over 6. Yes?
Switch the numerator and denominator in the other.
Oh, I made a mistake. Thank you for letting me know. 6 over 5, 6 over 5, 6 over 5. Thanks. Okay, but still, I have an isolated x. I continue. To isolate x, I moved 1 to the other side. Minus 2x is left. ln of 6 over 5. I move this 1 to the other side. It becomes negative 1. And then finally, to isolate x, I divide everything by minus 2. So if I divide everything by minus 2, this minus 1 divided by minus 2 becomes positive 1/2. But this one, I can write minus a half ln of 5 over 6. So that's my answer. If you want to find approximate values, of course, you have to use your calculator. But when I say the exact value, I mean this.
Or do you prefer to write
Again.
expanded?
No, again, I made a mistake here. Let me just do it correctly. By the way, let me just do it for your... So let me just write 5 over 6. But do you agree with me, if I write 5 over 6, I can turn it to a plus?
Yeah.
So let me write it first correctly. Yes, this is 6 over 5. So let me write 6 over 5. I divided everything by minus 2. This becomes positive 1/2. This becomes negative 1/2. Now my question is that might be you see the faucet and you see this answer in the faucet. I want you to understand that they are really the same. Yes? Are they?
Yeah.
Yes, why?
If you split it up, it becomes, in the first case, it becomes ln of 6 minus ln of 5, and if you just take out
Yeah,
the
this
minus,
is one way of saying that. Another way of saying that is that you know that if I have ln of any number to power minus 1, minus 1 goes back, it becomes minus ln of x. And then if I ask you ln of 6 over 5, 6 over 5, I can write it as 5 over 6 to the power of -1. Do you agree? Because 6 over 5 and 5 over 6 to power -1, they are exactly the same numbers. And then you see that this minus sign goes, this -1 goes to the back, it becomes this. So that's also good to know. It's good to be fast. If you have ln of a fraction, you can swap them, but the price that you have to pay is to have an extra negative sign behind. So this is correct. If you check the faucet, that's also correct. But I don't think it's your question. What was your question?
No, or do you prefer to write the answer expanded form?
I don't see, of course, I always prefer to simplify as much as I can,
Yeah.
but I don't think there is a way to simplify it that much.
I mean, we could like factorize it, of course, or we could expand it by changing the ln to ln of 6 minus ln of 5, or ln of.
Is it better?
I don't know, but it's at least it's.
I think that is very hard to judge here.
Yeah.
Yeah, but if you think you can make it more beautiful to your eyes, just do it. Yes, because I usually do that. But anyway, for example, in this previous case, I really prefer not to stop here. I prefer to stop there. But here, I checked it a little bit in my head. I didn't see any good way to calculate it and write it nicer, so I stopped there. But if you want, you can manipulate it a little bit more. But that's completely enough. Any questions here? Okay, so let us make the question a little bit harder. Not harder, let me just, this is also a good example. Let me see how can you do that. So number 4, the question is e to power 2x is 3e to power x. So we want to solve this equation. What do you think? What do you say?
Take the natural logarithm both sides.
Okay, so if you prefer, we can do that. I was thinking a different way. So let me follow yours, okay? So let me just method 1. Let us see if it works or not. So what you're suggesting is that take ln from both sides immediately.
Yeah.
Okay, so let us just do that. So then it becomes ln of e to power 2x. On the right hand side, I will have ln 3 times e to power x.
Yeah.
Yes, it seems it's working because now this 2x goes back. It becomes 2x. ln of e. What is your suggestion for the right hand side?
Where it becomes
ln of 3
Plus. That's the only thing I can do. That's a product. ln of a product can be written as the sum of 2 ln's, yes? Okay, so 2x, this is a famous number. I told you ln of e is 1. ln of 3 is not a famous number, so we have to live with that. But this one, I put x to the back again, this becomes ln of e. But ln of e is again 1. So finally, I have this equation, 2x is equal to ln of 3 plus x. And this is a very, very simple equation. I want to isolate x, so I move this x to the left. 2x minus x becomes x. So that's my answer. Yes?
After ln brackets 3e to the power x, if you remove the brackets, what happens then? Does it
No, you are not allowed to remove here.
Yes.
No, you cannot, because when two numbers are equal, the ln of the whole left-hand side is equal to the ln of the whole right-hand side. I mean, so I myself prefer to put that pair of brackets. If you write this, might be still I will imagine it like this, but it's a little bit ambiguous. I prefer to put the pair of brackets around it. Is that clear? So this is working, but the way that I wanted to do it was much simpler, I think. Can you say what I was supposed to do? This is completely okay. Yes?
Maybe divide by e to the power.
Yeah, divide by e to the power of x from the beginning. But you have to be careful. When you want to divide, am I allowed to divide? I'm allowed to divide unless that number is 0. But it is guaranteed that e to power x is not 0. Okay? Even though I don't know x yet, but it doesn't matter. E to power x is never 0. Because of that, I am on the safe side to divide by e to power x. And this might be easier, because if I divide by e to power x, I will get this situation. Yes? And of course, you can also do this in your head. But e to power 2x divided by e to power x, what's the answer? It becomes simply e to power x is equal to 3. And then what is x? X is ln of 3. Yes? You take ln from both sides, so that is exactly the same answer. Okay, so let me make it a little bit more interesting. So this question. Number 5. The equation is this. E to power 2x plus 12 is equal to 7e to power x. I wait a little bit for you, okay? Okay, can you see what is the trick?
I want to make a 12 logarithm.
So no one?
Yes. Ln of 7 divided by 10.
I don't know, but the method I am talking about.
The method. Okay, so I started by turning the entire equation into logarithms only. Natural logarithm.
Is it possible? But let us see, because if you have made a mistake, that's a good lesson for everyone. Let us see. I don't see any way to do it. Just I want to hear from you first. Okay, so what I'm supposed to do?
I think I see where I did a mistake.
Okay. Because that was not possible. Any other suggestions?
I want to make 12.
So what do you remember something? Yeah. Auxiliary variable. Yes. But if I introduce, I would say that let e to power x be some new variable. So let me call it t. Yes. Then what happens? Then e to power 2x becomes what? 2 to the power of 2, and that's a quadratic equation. It's as simple as that. So this becomes t squared plus 12 is 7t. Now you have to solve this equation. Yes? So then what happens? It becomes t squared minus 7t plus 12 equals to 0. Of course, you can use PQ or ABC formula, but I think the numbers are so famous, I myself prefer to do factorization. So I ask myself, I need two integers whose sum is negative 7 and the product is positive 12. What are those numbers?
4 and 3.
Yeah, but with negative signs, yes. Minus 3, minus 4. If I add them, if you don't want to guess, you can use PQ formula, of course, but this is not hard. So then it means that t is 3 or t is 4. But t, of course, is not my concern. My concern is to find x. I would say that, okay, now t is 3. This means that e to power x is 3. Okay, then what is x? X is ln of 3. So that is one solution. Another solution is that t is equal to 4. This means that e to the power of x is 4. Then it means that x is ln of 4. If you want, you can write 2 ln of 2, but it doesn't matter that much. Yes? So these are the answers. Okay, one question. Assume that I get negative 4. Of course, in this case, it is 4. But let us pretend that this is negative 4. How do you proceed? It's not possible. So there are no solutions to this. Because e to power x is always positive. It cannot be negative. Even if you take, naively, if you take logarithm, it becomes ln of minus 4. But I told you ln of minus 4 is not defined. So be careful about this point as well. Okay, so these are some examples of exponential functions. Let us also do some examples on logarithmic functions. Logarithmic equations. Sorry. Okay, so this was number 5. Number 6. Okay, let me write this. 2 ln of 1 minus 3x is 4. Now, the unknown is inside the natural logarithm, x. Okay, so what should I do? I will try to isolate x, but the point is that to isolate x, the first thing comes to mind is to divide by 2, of course. Okay, but can you tell me what is the next step? I want to isolate x, so I have to get rid of this ln somehow. But hopefully you remember what is the trick. If I say ln of a is b, if you want, what can you conclude?
A equals
E to the power of b. So it means that e to power b is equal to a. Of course, that is also reversible as far as a and b satisfy the conditions. Oh, the only condition that matters is that a should be positive. B can be negative, don't worry about b, but a has to be positive. Okay, now hopefully you agree with me. What is the next step here? This is playing the role of a, this is playing the role of b, then it becomes 1 minus 3x is e to power 2. But e power 2 is just a number. Okay, so you just keep it like this and then try to isolate your x. So you move this to the other side, it becomes e squared minus 1, and you divide everything by 3, by minus 3 to isolate x. So if you want, I can write 1 minus e squared divided by 3. So I take the minus sign away and I flip these two. You can divide them separately, it doesn't matter. Just do it according to your taste. Yeah, so that's the answer. But in the logarithmic equations, you have to be a little bit careful. Do you remember we had something like this even in Math 2C? What should I be careful about? Of course, in this case, it doesn't happen, but the point is that might be this is a fake root. Because sometimes, of course, here, this is not a fake root. Why it is not a fake root? The source of error in the fake root is that one of these operations is not reversible, at least. In that case, you have to be worried. But in this case, let us check. Can I go from here to here? The answer is yes. Can I go back from here to there? Yes, I just multiplied by 2. So far, this operation is reversible. But what about this operation? From here to here, I can, of course, go. But do you think I can go back from here to here? Yes, by taking ln. So that's also reversible. Then, of course, everything clear that all of them are reversible. So in this case, I really don't need to bother about if this is a fake root or not, because all these operations are reversible. So this means this statement is equivalent to the last statement. So there is no danger of a fake root, yes.
When should it not be reversible?
Yeah, sometimes it is
Yeah,
possible.
well, how would you have to change this question?
No, this is what here. No, I will give you some questions, okay, that you will see. But the point is that this is not a good way, because sometimes if the equation is complicated, I have to think about all the steps. My suggestion for you is to make sure that the answer that you get doesn't make any problems to the original equation by making this negative or something like that. That is somehow easier. Or might be you prefer a combination of both. Be creative. Do it in your own way. So for example, number 7, let me write another one. So let me try to see if I can, ln of x minus 2 plus ln of x minus 3 is equal to I don't know, let me just write ln of x. Let me just wait a little bit, minus 5. Yeah, let me make this positive and this one positive, and let me make this one 5 plus ln of x. Okay, so assume that we want to solve this equation. If your equation is a logarithmic equation, you need to think in this way. You have to get rid of the ln's. Okay, so and then one way to get rid of ln is this situation, that you have one single ln and a number, or you have this situation. If you have equality of two ln's, then you can also conclude that these two are equal. So when you want to solve a logarithmic equation, you have two alternatives. Either to think in a way that you can write something like this with one single ln and a number, or equality of two ln's. In both cases, you can immediately get rid of the ln sign. In this case, e to power b becomes a, so there are no ln's involved anymore. In this case, you have equality of these two without any ln's. So that should be in the back of your head if you want to simplify things. So I don't know which one you prefer, for example, here. Do you have any suggestions how to do it here? Yes? No, be careful. If you think dividing by ln I can get rid of, that is wrong. Be careful. If I write ln of x divide, I am not dividing here. Might be that was my wrong impression I gave to you. I didn't divide ln. ln is nothing. It's just a symbol. If you put a number in front of it, then the whole package becomes a number. So ln is not an independent identity. It is like sign. I cannot divide by sin or by cos, yes? These are not numbers. When I put an angle in front of it, then the whole package becomes a number. Exactly the same situation. Might be I should have been careful. I didn't drop ln. I am saying that if the logarithm of two numbers are equal, then you can conclude the numbers are equal. This is different from saying that I am dropping the ln sign. So be careful. This is a common mistake. That was good that you asked about. Yes?
Well, first of all, is this question correct?
I don't know if it's correct or not. There is nothing wrong about equations. The equations are either having solutions or not.
The solution is undefined as far as I can.
Okay.
So you just combine them.
Combine them back, yes? So for example, this is the sum of two ln's. I can combine them back into one single ln, provided to write this. Yes? But then let me put another pair of brackets around that. Okay, and now I will do the same thing there. So it becomes what?
5x.
5x. But the point is that let me just practice right here. From here, I can go here.
Yes.
But is it reversible? No. So it is not reversible. That's what I'm saying. Thinking about if these operations are reversible takes more time than checking that if the answer works or not. Why this is not reversible, by the way? So do you remember when I wrote this formula for you, I always emphasized something. This is, if I say that, let me say, when you see this, this means for all x, for all y. This is true or false?
It's not true for all.
So it is not, no, it is not true for that, don't discuss. In mathematics, it is either true, a statement is either true or false. So this is true or false? It's false. So this is why I always mention for all x positive and for all y positive, yes, in that case they are equal. Okay? But we don't know if x plus 2 or x plus 3 are positive. Okay?
So that's why it's undefined.
So we cannot say that this is reversible. I just want you to say that because let me tell you something. Is this one defined or not? This makes sense or not? This makes sense because minus 2 times minus 3 is 6 and ln of 6 is okay. But if you want to naively use this formula, then you will be in trouble because this becomes ln of minus 2 plus ln of minus 3. I cannot say that this is equal to this because this is nonsense, yes? And the reason is that this happens because I decided for some reason not to respect these conditions. So whenever you read a formula in mathematics, you have to learn about the domain of applicability of the formula. So I want to say that if I respect these, then yes, this is reversible. Okay, but there is no guarantee yet. I don't know x. When I don't know x, I don't know if x plus 2 is positive. I don't know if x plus 3 is positive. So this is not reversible. I want you to understand that. Okay. So, but I don't want to follow this method, so I don't care. I will continue and find the solution to see if it works or not. Okay, so for example, let us go one more step. Can I would say that ln of a number, whatever it is equal to ln of another number. If this is true, then what can I conclude? If that this number is also equal to that number. Yes? And then x to the power of 2, I add them, it becomes 5x plus 6. And as you said, there are no answers, yes? Because this one and that one are cancelled, and x2 plus 6 is equal to 0. So there are no solutions. Why is that? Because x squared cannot be negative 6. So there is nothing wrong with the equation. That is the answer to this equation. There are no solutions.
Because it feels like the original equation has to be incorrect. Because
No, there is no meaning to say that an equation is incorrect.
no, but
There
since
are just rules that have to be added for it to be.
because if x is, if we figure out that x is undefined, then that would mean that like either side of that equation would become undefined.
Well, it means it's not a true equality.
And then it can state that some.
No, it is not clear because, for example, I can choose x to be 5. For 5, the left-hand side makes sense, the right-hand side also makes sense, but that is, of course, they are not equal.
Yeah, but there's no such value for x.
Okay, how should I know that until I solve the equation?
Yeah, but I mean, I know.
No, I mean the logic that you are talking about, if I understand it correctly, doesn't make sense to me. Because the point is that if you can, even if you can show that this cannot hold for any number, then it means from the beginning you can say there are no solutions.
Yeah.
Instead of going through this long process, you can say for this reason there are no solutions. I cannot, for example, let me just give you an example. I would say ln of minus 1 minus x plus ln x minus 5 is equal to, for example, ln of x, something like this. If I ask you to solve this, again, this is not correct to say the equation is wrong. You can say the equation doesn't have any solutions, but you can do it wiser. I would say that, okay, to this one to make sense, x should be smaller than 1. This one makes sense only if x is greater than 5. And these two conditions cannot simultaneously be met. So exactly what you are saying is just a solution for this equation not having a solution.
Yeah, but I guess like can an equation be correct if it has no solution?
Yes. No, correct. I mean, an equation is a statement that we want to make it right. We want to find the solution set for the equation. In that case, because you don't have a studied set theory, because in principle, instead of saying solve the equation, people usually in more advanced texts ask you find the solution set of that equation. And if there are no sets, then you say that the solution set is the empty set. Yeah. So, but as far as I understand, it is not a correct way of expressing things that this equation is wrong. Yes, this means in another language, it means that if you ask GeoGebra to draw the graph of this function and another one draw the graph of this function, there is nothing wrong with that. This means that these two graphs do not intersect. That's exactly the meaning. So there is nothing wrong about it. That's what I'm saying. Anyway, is that understandable? Okay, so let me. By the way, when I look at my questions 2 or 3 years back, I realized that I was a little bit cruel because my questions back then were much harder. Okay, so let me give you one of my questions that I asked the students to solve when they were doing Math 3C. So I want to give you, and I designed them purposely a little bit hard. And so this is my equation I designed for an exam question. And I gave it only, of course, 2 A points. But let me see how you can solve it. The equation is this. ln of x minus 4, and then I have plus ln of x plus 5, and then is equal to 2 ln of the square root of 2, and plus ln of 1 minus 4x. Okay, this is number 8. This is my exam 2019, 12th of December. So in principle, you should have an exam by today or tomorrow. Yes. No, 2 days back. So for me, the final answer or answers are important. Do you have them?
Yes. Is it minus 3 and minus 4?
Both of them?
Yeah.
Okay, let us see. Any other solutions?
Wait, what?
You said minus 3 and minus 4.
Minus 3 and minus 6.
Minus 3 and minus 6.
But there are actually no solutions to the. All of them are.
I think this is
Okay.
fine.
It's wrong.
It's a fine.
No, but I told you that even if that is the case, you shouldn't say it is wrong. You should say svar, there are no solutions.
Yeah, wait.
And that is the correct phrase for the solution of the problem. But if you say the equation is wrong, it is meaningless.
Never mind. I think it's 2 and 11.
Yes? So both of them are negative. Okay. What are the negative numbers? No, but you need to get in. So, for example, Simon gave me the answers -3 and -6, you said? Okay. So you got the answers, and then you say, for this reason, these are fake roots. Okay. 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 That's a different story. Yes?
I got -11 and 2.
-11 and 2. So let us check. Okay. So well, at least you can tell me what did you do with this part at 2 ln square root of 2? Yes, you bring it up and it becomes ln of 2. Yes? So in the left hand side, do you agree that I can write what? X minus 4, x plus 5, and then I put a pair of brackets around that. So I collect it in this form. Yes, I have written everything right. And then here on the right hand side, I move it on top. And then I have ln of 1 minus 4x. Here, of course, if you don't mind, let me just multiply it. X times x is x squared. X times 5 minus 4 times x minus 4 times 5. This becomes a square root of 2 to power 2, which is ln of 2. And then I have ln of 1 minus 4x. And I simplify the left-hand side, so it becomes ln of what? X squared plus x minus 20. And then the same story here. I can write 1 ln and multiply them. But let us multiply them in one go. It becomes 2 minus 8x. Do you agree with me so far? Okay, now ln of a number is equal to ln of another number. Be careful, I am not dividing by ln. The result is the same as if I am dividing, but this is meaningless to divide by ln. But this conclusion is anyway correct. Yes? So I move this to the other side, it becomes x squared plus 9x minus what? 22. Is that the equation everyone got? X squared plus 9x minus 22. Am I right or not? And if I want to solve that, if I can solve it using factorization, it is easier for us, yes? Can you guess two numbers whose product is minus 22 and this is positive? Positive 11, negative 2. So this becomes x, positive 11, negative 2. Yes? Understandable? So this means that the solutions are either minus 11 or 2. Yes, but be careful because it's a logarithmic equation. To be honest, what is happening? I didn't solve the original equation. I simplified that, but the solution starts here. So I'm actually solving this equation, and there is no guarantee that this equation is equivalent to that equation. Okay, so x equals to minus 11, x equals to 2. Is all of them acceptable or not? Both are unacceptable. Let us check. Minus 11 is not acceptable because it makes some problems, at least for this one. Minus 11 minus 4 is minus 15. ln of minus 15 is not defined. But what about 2? 2 also make the same problem. So none of them is acceptable. So both are fake roots.
So it was the same step unreversible this time around?
Yeah, definitely.
No,
We can check which one is not working. Both are false roots. So what you need to, first of all, what you need to write in the exam, there are no solutions. This is what you need to prepare. But if you want, we can see which part is going wrong. Okay? And then it is not that hard to understand. So all of them are possible to go in this direction. This is for sure. This is possible. Even this is also possible. This is also possible to go back from here, go back from here, to go back from, okay, this you have to be careful. Can I go back from here to there?
Not necessarily.
Uh,
I think so. No.
if two numbers are equal, there is no guarantee that their ln's are equal.
Yeah.
Because might be the ln's are not defined in the first place.
Yeah, the first one, the left part should always work.
No, I mean, for example, if I
But the
choose
second
2,
part doesn't.
you see if I choose 2, this is negative,
Yeah.
this is also negative. So it is not reversible from here.
Yeah, never mind.
If two numbers are equal, there is no guarantee that the ln's are the same unless they are positive, which in this case there are. So you see that there should be somewhere that it is not reversible. Otherwise, if everything is reversible, no false roots. Okay? Okay. So this is also some intuition. Some students only throw away the negative value. So be careful. That is not the idea. The idea is that the whole expression should work. So in this case, both the negative one and even the positive one are not acceptable. So just that the number is negative, throw it away. This is not the logic. The logic is that the numbers, for example, if I have this situation only, for example, this minus 11 is even good for the last one. 2 is bad for the last one. Yes, because if I choose 2, this becomes undefined. But if I choose minus 11, this becomes defined. So you have to be careful that the logarithms should be defined, not I throw the negative one away, keep the positive one. Okay. So still you didn't solve it correctly, or did you?
Yeah, I solved it.
Okay, so good. Yes, but you have to be careful when it comes to the exam. Okay, any questions? Okay, so let us see. The lesson is actually finished here, but this chapter is, I need to complete it next week, and then everything in this chapter will also be finished. There is a question here I see in this book. It is tempting to solve it, you know. So this is the question. Can you answer this without calculator? So this is 5 to the power of log of 7 to the base 2. Yes, minus 7 to the base, to the power of log 5 to the base 2. Yes. So there are 4 answers. It's a multiple choice question. Without the calculator is not allowed. The answers are 5, 0, 7, 2. 5, 0, 7, and 2. Another one for you. Without this was level 2. This is level 3. So calculate the logarithm to the base 36 of this number. Square root of 12 plus 6 square root of 3 minus the square root of 12 minus 6 square root of 3. Yeah. The base is 36. You're supposed to calculate this. Of course, I think that this is also a multiple choice question. No, this is not multiple choice. You have to calculate it. Find the exact value of this expression. Here I made a mistake. This is plus. This one is plus. Yes, that one is plus.
Då kunde jag göra log 5 cos 2, vilket är det som är
I want to give you some hint. Might be you don't even know what to do. So this question, let me give you a hint. I want you to prove these two numbers are equal.
Which
This number is exactly equal to this number, so the difference is 0. You shouldn't do calculation, but you have to prove why these two numbers are equal. You have already no. So why they are equal?
So the 5 we can turn into 2 to the power of log 5 with the base 2. And the 7 we can turn into 2 to the power of log 7.
Just can you repeat it again? So for example, you are saying that the question mark is equal. Instead of 5, what do you write?
2 to the power of log 5 with base 2.
So first of all, everyone agrees that this is correct. Because 2 to the power of log 5 to the base 2, do you remember everything will be cancelled? 5 is left. So Simon is actually writing this 5 in this form. And then, of course, there is another power there. Yes? Yes? Okay, minus. Okay, what do you do then?
2 to the power of log 7 with base 2.
So instead of 7, for this with the same strategy, you write this. And this is, if I ask you what this number is, you would say 7. So this is sitting instead of this 7. And then I copy and paste that power there, yes? But then everything should be clear for you now, yes? Because 2 to some power to another power, I write 2 and I multiply the powers, yes? This becomes log of 5 to the base 2, log of 7 to the base 2, minus, this is 2 to the power of multiplying these powers. Yes, so this was very good, yes. And everyone sees that these are the same, yes? Because this is log 5 to base 2 times log 7 to base 2. Whatever this number is, that number is the same. And the bases are also the same. I'm subtracting them, so this becomes definitely 0.
why did oh, alright.
So that was the same trick I used to prove the derivative of exponential function, but he actually used it out of the box. So you took that an idea, the same idea, but you applied it here and it works. So that is 0. Thank you. But what about the next one? So this was a level 2 according to them. But even this is more advanced than level 3 problem here. But now we go here.
Papa,
Yes?
I don't remember the rule. It was the rule that if you have like a power, no.
Yes, I can write that rule for you if you want to. If I have log of x to power p to the base b, this p go directly there.
No, but the other one.
But if I have power here,
Yes, on the base.
we had this before. This is not in your book, but I talked about that. This becomes reciprocal and goes back.
Yeah.
So if you these are the formulas. Of course, you are right. Might be at some point we need to write 6 to power 2 here. But the main obstacle here is not the base for the time being, because this is a sum, and unfortunately we do not have any formula for the log of sum of two numbers. Log of a plus b cannot be written anything. It's just log of a plus b. Okay, I want to give you a hint because we are actually running out of time. So what I would say is that forget about the log part for the time being. Try to make sense something here. I don't know, by the way, if you can solve it or not. But I would say I will start with this sentence. Let x be that unknown number. Let this. How can this will help me?
Yeah, wait, this. I don't think this will.
What do you think I will do next?
I mean,
Because the main obstacle in front of me are these big square roots.
we can factorize, or figure out a factor for 12,
Mm-hmm.
or factorize 12 with 9, or whatever you would say, so that we have 9 or square root of 3 times something. That should
Yes.
equal to.
Yes. I think it is possible. I didn't think about that way. It might be it works. I will come back to your method. But here I was thinking to get rid of these squared signs. I raise it to power 2. Okay, my goal is to find x. I raise it to power 2. X squared becomes. Be careful. It seems horrible, but it is not. Because the first one squared becomes what? 12 plus 6 square root of 3. Plus, can you tell me what happens because I will have 2 times the first one times the second one? But it seems horrible, but it is not at all, because it becomes 2 this times that. But what happens when I multiply them? It becomes a square root. Then this will be multiplied here, but this is conjugate rule. Yes, so it becomes the first one to power 2, which is 144, minus the second one to power 2. 6 square root of 3 to power 2 is 36 times 3, which is 108. And then plus the second one to power 2. Do you agree? So I gave it a name, and I raised both sides to power 2, x squared. The first one squared becomes this one. The second one squared becomes this one. 2 times the first one times the second one becomes that. But now look at what happens. This one and that one are gone. This 12 here and that 12 there are added. It becomes 24. But what is this number? 144 minus 108 is 36. Square root of 36 is 6. Times 2 is 12. Times 2 is 12. Yes? Yes? I am done. Yes? Because this becomes 36. Do you remember I was looking for x? I was not able to find x. I square it. I was lucky. X squared becomes 36. But then what is x? So that's also a miracle, isn't it? This number is exactly 6. So this number is 6, and now you put it back there. So this question mark is logarithm of 6 to the base 36. Yes? And this might be needed now, because 36 is 6 to power 2, 6. This 2 goes back, but it becomes reciprocal and goes back. And then I have log of 6 to the base 6, which is 1. So this number, this question mark is 0.5 or 1/2. So sometimes this trick is good. You see, I wanted to calculate this. It was more or less hopeless. Then I wanted to get rid of the square roots. I raise it to power 2, and then something happens, yes? Because the person who has designed the question had something in mind like me, yes? And then I realized that even though calculating x is hard, but calculating x squared is easy, it becomes 36. And of course, by the way, there are 2 answers, positive or negative. Why did I choose the positive 6 here? No, that is not under my control. But what I'm saying is that how do you know that this number is 6, not negative 6? It is clear because this is positive. This is also positive. I am adding them. So I knew from the beginning x is positive. Not because I cannot put it there, so I choose the positive one. Yes? This is the illogic. Okay, so that's also some questions about logarithms here. If you want, I can write a level 4 problem here for you, but we will not have time to solve it. You can solve it later, yes.
Because my method did not work.
No, it is working, I think, for you.
Or I
So let me see. For if I want to use your method, that is easier even. So 12 plus 6 square root of 3, I will write it like this. Instead of 12, I would write a square root of 3 to power 2 plus 3 to power 2. Yes? It becomes 9 plus 3, which is 12. And instead of 6 square root of 3, I would write 2 times square root of 3 times 3.
Okay, yeah.
Do you agree?
I'm
Because
sure.
this is exactly this one. But this is the squaring pattern.
Oh yeah.
So that is easier, your method.
That's not my method, but
No, because I thought that you said something like this.
No need to try to rewrite 12 as.
So I wrote 12 as this one and that one.
No, I wrote it as 4 divided by 3 times square root of 3, or 4 divided by 3 times 9, or 12 divided by 9 times 9.
So it did work or not?
It didn't work for the second square root, because then I got 4 divided by 3 minus 6, which would be negative, I think. Yeah.
Because this is working now, you see? Because this is this one to power 2. So when I take the square root of this power of 2 is gone. And that is exactly the same thing with the negative sign.
Yeah, that worked, but I don't know.
No, but then also there is something tricky, might be. So let me just solve it in that way. So do you understand what I mean? If you can understand for some reason the way that I did it, so you can, instead of this one, you can write a square root of 3 plus 3 to power 2. Everyone agrees. Because the first one to power 2 is 3. The second one to power 2 is 9. When I add them, it becomes 12. 2 times the first one times the second one becomes exactly this number. And if what will happen for the next one becomes the square root of 3 minus 3 to power 2. The first one squared, the second one squared gives me 2 times the first one times the second one. But be careful. A square root of x squared is not x. That is a lie.
Yeah.
This should be absolute value of x. And that is important here, because then it becomes a square root of 3 plus 3 absolute value, plus absolute value of a square root of 3 minus 3. But absolute value of this number and the number itself are equal, because this number is positive. So this becomes square root of 3 plus 3. But the absolute value of this is the other way around.
Yeah.
It becomes 3 minus the square root of 3. And then this one and that one are gone, so I will get the 6 again.
Yeah, but because if you just try to replace 12 with 4 over 3 times square root of 3.
So 12 is what?
4 over 3 times square root of 3.
To the power of 2?
No, just square root of 3.
Because this is not 12 now.
I mean,
And 12 is not equal to this.
Because 12 is equal to 12 divided by 9 times 9.
Yes. 12 is equal to
12 divided by 9.
12 divided by 9 times 9.
Yeah, and 12 divided by 9, when you divide that by 4, like...
It becomes 4 over 3.
Yeah.
But times 9.
Yeah, times 9.
Not times the square root of 3.
Yeah, but... No, wait, what was this?
I don't know what you have
I don't know
done.
what it was from.
Yes. This is correct, but this has nothing to do with that one. You are showing me this and you want to sell me this. This is not working, yes?
Yeah, no.
Yeah. But this method is also working. I mean, so do you understand that why I flipped the sign? Because a square root of 3 is smaller than 3. So a square root of 3 minus 3 is a negative number. Absolute value means the distance from the origin, and the distance is not negative. So when I say the distance of this number from this number to the origin, it is the other way around. And if you don't pay attention to this, be careful. 3's will cancel, and you will get 2 square root of 3, which is totally wrong. So that's important to realize. And write it somewhere. Square root of x squared is not x. It is absolute value of x. Okay, so that's also some interesting problems. I can write one for you if you have time. I don't know even myself can solve the problem, but I can write it here to see what is the other way. If you are interested in hard problems, that you should, by the way, be interested. So this is the problem. You are supposed to solve this equation. Logarithm of 1 plus 4 over x. You know that when I put 2 here, this is common. This means the whole logarithm to power 2. So let me write here logarithm to the power of px. When you see this symbol, it means logarithm of x totally to power p. And it doesn't matter if you have also a base b. So this is common. We use this. And then plus logarithm, this time the base is 2. And then you have 1 minus 4 over x plus 4 is equal to 2 logarithm to the power of 2 of 2 over x minus 1 minus 1. This is also interesting. Solve this system. Logarithm of x to the base y minus logarithm y to the base x is equal to 8 over 3. And then you have x times y equals to 16. This is a system. That is one problem. That is the second problem. But let me just double check that I have written everything. 1 plus... Yes. Yeah, that's correct. Yeah, you can think about it if you're interested, and if you get stuck, we can discuss a little bit about that later. Okay, thank you.